Okay, on last night's homework, you had number 34. That looks something like this. You're adding two fractions. We haven't learned this, but because we know how to now rewrite fractions with a LCD, you should be able to add fractions together. So let me show you. Well, do we know how to rewrite them with the LCD then? Right? We know how to do that. So let's just do that first then. Let's rewrite them with the LCD, and I'll show you how to add them. Because once you have the LCD, adding fractions should be really straightforward. So yeah, you factor out the denominator. So Jason, how would you factor the denominator first?
The GCF of x.
Yeah, and then you would just get this x times x minus 4. By the way, do I like the way it's written 4 minus x? No, that's not in standard form. So you want to write things in standard form, don't you? So I did. And do I like the negative in front of the x? How do I get rid of that negative? I can just multiply the denominator by -1. If you're going to do that, you got to multiply the numerator also by -1. You can't just all of a sudden multiply a number by -1, right? That doesn't make any sense, right? You see what I mean? So what I'm going to do first is I'm going to factor out a -1 from the denominator of negative x plus 4 because I would like my first coefficient to be positive. Then, since it's a fraction, I can multiply top and bottom by. How do I get rid of this -1? How do I move it up to the numerator, in other words? Multiply top and bottom of this fraction by -1 over -1. Is that okay? Can I multiply a fraction by -1 over -1? Yeah. What's -1 over -1? 1. It just gets rid of that 1 on the denominator. I don't like fractions, right? I mean, I don't want negative numbers on the denominator. So, as you can see then, it just simply becomes this. Okay. 4 over x times x minus 4, -1 over x minus 4. Now, what's my GCF? Well, you list all the factors that were used in both of the denominators and choose the highest exponent. Well, we don't have to worry about the exponents here because the exponent is just 1 for everything. What is my GCF? Who could tell me? Yes, Samuel? Is x minus 4 my GCF? That's the greatest common denominator. That's GCF. I'm sorry, yeah, that's GCF, you're right. Am I looking for GCF? I'm looking for the LCD, the least common denominator. You're right. GCF is x minus 4, you're right. But that's not what we're looking for. We need a common denominator. So then how do you find the least common denominator? You write down, Samuel, write all the factors, right? What were all the factors that we used in both of these? And x and -4 were the factors. Are you looking at this binomial? X is not a factor. This whole thing is a binomial, x minus 4. Factors are what's multiplying. Two things. X is a factor. What else is a factor? X minus 4. The whole thing is a factor. Hello? Is -4 a factor? No, -4 is subtracting x. It's not multiplying something, is it? Yeah, the whole thing in the parentheses, x minus 4 is a factor. So my LCD class is what? X times x minus 4, isn't that right? Yes?
Yeah.
So do you see why I need to multiply? The first fraction, I don't need to multiply by anything because it already has the... It already has the...
Already
has it has the LCD. It already has x times x minus 4. But the one on the right, it doesn't have the x. So I'm going to multiply top and bottom of this by x. And so now you get a fraction with a least common denominator. Yes? Okay. So now, do you know how to multiply two fractions with least LCD? Look, how do you add 1/3 and 2/3, guys? They have a common denominator. You just add the numerators and keep the same denominator. Same way with this. Look, you have the common denominator on both of them. Do you know how to add these two fractions?
Yes.
Michael, what do you do? How do I add these two fractions when they have a common denominator this way?
Add the numerator?
Yeah, add the numerators. So you get 4 plus -x, right? Am I done?
No.
No, of course. What about the denominator?
Just say
It stays the same. Just like, when you add 1/3 plus 2/3, doesn't the denominator stay the same? Right? It's the same idea. Instead of having denominator with some number, now we have it with some polynomials that are factored. Do you see the idea? So do you see why you could actually add and subtract fractions now? Now that we know how to rewrite fractions with their LCD, you should be able to add and subtract. Okay? We say, wait a minute, shouldn't we multiply the denominators out? And I said, remember I always told you whenever you do these fractions, you want to always leave it factored, right? Let me show you why. Because if you leave it this way, it's not right. Yeah, you have to check and see if things cancel out. Look at the numerator. Okay, Samuel, this is going to answer your question. Look at the numerator. 4 minus negative x. Is that the best way to write a polynomial? How should you rewrite this? How about Kali?
Me?
Yes. Instead of writing 4 plus negative x, you should write.
Oh, you can factor out negative 1.
Yeah, you should always rewrite things in standard form. And when you do, you get negative x plus 4. And do we like negative in front of the x again? No. What should you do? Factor out the negative 1. Look what happens when you factor out the negative 1. Thank you. When you factor out the negative 1, do you see how you have a common factor on the numerator and the denominator? Right? If you multiply the bottom, the denominator, if you multiply it out, would you have been able to see the common factors? That's why I want you to leave it factored. Does that make sense? Because it may cancel out. At the very end, when you're done simplifying, if it doesn't cancel out, then yeah, you can multiply it out. But you don't want to do that before. So what's the answer, class? What's it come out to? Negative 1 over x. You see how you should always write things in standard form and factor out as much as you can? Because things might cancel out at the end. And we don't like negative leading coefficient, right? We want it to be positive, so that's why I factor out a negative 1. Okay. All right. Okay, so let's take a look at number 36. It's written this way. Y minus 2 over y divided by y plus 2 over y. Now, you have to follow the order of operation, don't you? So you got two parentheses. Patty, what should I do with these? So I got y minus 2y. Is there a way to subtract these together? We haven't learned this, but let me ask you, what's y really in terms of a fraction? Y over? Yeah, y over 1. Is that okay if I write y over 1 here? What is y here again? Y over 1. Okay, so Patty, can I subtract these two fractions as it is? No. Whenever you add or subtract fractions, class, what do you need? Common denominator. Is there a way to make this y over 1 and 2y with a common denominator? What would the common denominator, class? Y. So guess what? I'm going to multiply top and bottom of this by y over y. Is that okay? Because then I would get common denominator of y. This is easy to see what the common denominator is. 1 and y. What's the common denominator? Y, right? What about this one? Top and bottom by, multiply top and bottom by y over y again. And doesn't this simply become this? Yes? Okay. So this is kind of like the idea of having 2 plus 1/3, right? How do you add 2 and 1/3? Well, isn't 2 really 2 over 1? Multiply top and bottom by what? 3 over 3. So doesn't that become 6 over 3 plus 1/3? Same idea. You get that? So now that we could add these two fractions together, who could help me how to do this? So again, we have to follow the order of operation and deal with the parentheses first. Who could help me what I get? For the first fraction, what does that become? Yes, Libby?
Y squared minus 2 over y.
Good. What about the second fraction? What does that become? Song? The second fraction, when I add these together, we have a common denominator. What do we get? How do we add two fractions that has a common denominator? So, what is 6 over 3 plus 1/3? What is 6 over 3 plus 1/3? 7 over 3, right? Guess what? Instead of this, you have this common denominator of y. Guess what we do with the numerators here? Not quite. We're adding them. Y squared plus 2 over y. That's what we get. Do you see how we get this? Right? You have a common denominator. All you have to do is add the numerators together, and you keep the same denominator. Right? Just like 6 over 3 plus 3 is 7 over 3, right? So you just add the numerators here. All right. Then, what does it mean when you have division? Samara, what do you think? How do I rewrite this with a multiplication? Exactly. Times y over y squared. So this is what we get. Do you see how I changed the division into multiplication and rewrote its reciprocal? Then, how do I multiply these together? Well, before I do, guess what? Is y a factor of the whole numerator? Is y a factor of the whole denominator? In other words, can I rewrite it this way? Y over y times y squared minus 2 over y squared plus 2. Right? What's y over y, guys? 1. Can I cancel anything out with the y squared minus 1 and y squared plus 2 1? Can I cancel out y squared, y squared? Why not? You're right. I cannot do that. This would be wrong. You know what some people did? Like they canceled out y squared, 2 and 2, they put negative 1. Is that the right answer? Of course not. Why can I not cancel out y squared and negative 2 and 2? Eunice. Yeah, you have a subtraction here, addition. What does it mean when you cancel something out? Let's say that I cancel out y squared. That means you're dividing top and bottom by y squared, correct? Is the whole numerator divisible by y squared? In other words, does y squared go into y squared and also negative 2? No. What about the bottom? Does it go into y squared and 2? No. When you're canceling something out, you're dividing the whole numerator and the whole denominator by that number. Right? Those are not the factor of the whole numerator or denominator. You can't cancel those out. Right? So there's your answer. Any question? Does this make sense? Do you see why if you rewrite it this way, it makes it so much easier to, right? Without really blindly canceling things out, you know that this is something times something, then you can cancel these out, right? Y and Y's. Okay, may I move on to the next example then? Okay. All right, take a look at number 46. How would you solve? Because a lot of you had a question on this one. Tajwar, what would you do here?
First, you multiply y minus 3 and y plus 6.
Yes, you need to multiply those two binomials together. And?
You get, and on the other side, you do y minus 5 times y minus 5, not y squared minus
Yes. Does this become y squared minus 25?
No.
No. It means y minus 5 times y minus 5. If you multiply two binomials together, right?
Yeah.
You get a trinomial most of the time, right? So here, you got to do this times that and this times this. Hold on, let me see. Okay, so did you get this? Y squared plus 6y, okay? And then negative 3 times y, you get negative 3y. Negative 3 times positive 6, you get negative 18. On the right side, you get y squared minus, right? I actually wrote it separately. Y minus 5 times y minus 5, right? Y squared, kind of on the side. Minus 5y, and then negative 5y again, plus 25. So you should have gotten this. What happens with the y squared on the left, y squared on the right? They cancel out. You can subtract both sides by y squared, right? And then you have together the y. So I'm going to add 10y to both sides. Don't you get 13y minus 18 equals 25? Subtract 18. Then you get, you get 13y equals to 43, correct? Divide both sides by 13. The answer comes out to 43 over 13. Okay, so that's how you figure this one out. Okay. Any question? All right. May I show you the other ones? The word problems?
Yeah.
Anybody need help with the word problems at the end? No? Okay, if not, then I can stop here. Anybody need the word problems? Okay, let me show you real quick then. Okay, here. Number 43, it says you got a rectangle and then the consecutive sides are, the length and width are consecutive integers, right? So if width is w, guess what? The length must be w plus 1. So I say let w be the width, w plus 1 be the length. They told us the perimeter is 154, correct? So we start with the formula. How do you find a perimeter of a rectangle? How do you find the perimeter of a rectangle? Yes, Eric?
2w
Yeah, 2w times 2l? Plus, yeah, 2w plus 2l, right? So all you have to do is now plug it into the formula. What is the perimeter? They told us 154. What is the length, class? W plus 1. What's the w? What's the width? W. So there you go. You solve, right? And of course you distribute and you get 154 equals to 2w plus 2, right? You got to distribute this 2 right here. And plus 2w, you get 152 equals to 4w, right? You subtract 2 from both sides, right? When you do, w comes out to what, class? 38, doesn't it? If the width is 38, guess what? The length must be 39 because length is 1 more than the width, isn't that right? Because these are consecutive integers, correct? So there's your dimension, 38 by 39 centimeters. that okay? Tajwar, can you read number 50 for us?
Find two numbers whose sum is 13 and whose square is total 85.
Good. Find the numbers whose sum is what? 13. So how many unknowns do we have?
2.
2. How many variables can you use during first semester?
1.
1. So I'm going to let x to be my number. They told us the sum of the number is 13. So if x, you're adding two numbers together, it adds up to 13, right? So you guys remember this? We did this in the very beginning of the semester, right? If you and I have $13 together, and I have $5, how much do you guys have?
8.
8. Remember how if there are only two things and they tell you the total, you could figure out the other one? So if x is the number and if total of these two numbers is 13, what's the other number? How do you represent the other number using x? Yes? 13 minus x is correct. You guys remember this? Right? Their total number of 13, right? Total is 13. If x is one of the numbers, the other must be 13 minus x. Is it x minus 13? No, it's total minus whatever the x is, correct? If you don't believe me, add these together. What's x plus 13 minus x? 13. That should come out to the total of 13, right? Right. All right, so then they say, whose squares? Which ones are we squaring? 13 minus x and also x. You square both of these. Total. What does total mean? Add. You add the squares of these two, right? So you square the x and square the 13 minus x squared, you get 85, right? And of course, we know how to do this. Don't we know how to multiply 13 minus x times 13 minus x? We get 169 minus 26x plus x squared. Isn't that right? So that equals 85. Remember, whenever we solve these things, is this a linear equation? No. When you don't have a linear equation, what does it have to equal to? Whenever you solve, you gotta use zero product property. It has to equal to? No, it has to equal to 0. Right? Then you factor. You guys remember zero product property? So how do you make this equal to 0? Well, you simplify the left side and then subtract 85 from both sides. Right? You guys remember that? Whenever you have equations that are not linear, you gotta simplify. You gotta make it equal to 0. Right? And how do we factor that trinomial? Well, before you do anything, you should look for the GCF. Does it have a GCF?
Yes.
Yeah, it's got GCF of 2. Can I just divide both sides by 2 because it equals 0, the whole thing? So get rid of that, make it simple. So do you know how to factor this trinomial? What? So it's going to be x plus something times x plus something. 7 and?
6.
But do they have to be both negative? Don't they have to be both negative in order to get negative 13 in the middle? Yeah? So you get two solutions. X equals to what? 7 or x equals to?
6.
How do we get two possible solutions? Is that okay?
Yeah.
Yeah. But turns out this one's kind of interesting. If we for one of the solution, if x equals 7, guess what? The other number is 6 because they have to add up to 13, right? If we choose x equals to 6, the other number then is what? 7. So there's only one way for this to be true. The two numbers must be 7 and 6. How do we check this? Yes, Claire?
You replace x with 7 and 6.
Yeah, you could plug it. Yeah, so quick way of checking it is you add them together, it should equal to 13. Does that guarantee you that you have the right answer? No. You gotta square both of these and add it together, it should equal to what? 85. And does it work out? Yes, it does. So this one's kind of interesting. Even though it looks like there are two possible solutions, right? Solution of the one is the solution of the other. So there's really one way for this to be true. Okay, any question on this? Okay, yes? No, we got two solutions for it because but it just turns out that if we choose x equals 7, the other number is 6, and if you choose x equals 6, then the other number is 7. So, it's possible that some solutions are just more than one solution, right? It's possible for that to happen, right? In this case, either way, you get one possible solution. Two numbers are 7 and 6. Okay. Any question? All right, good.